All right. Okay, so my idea today, and I wanted if Matt joined, but Matt, oh, Mike. I guess if everyone's meeting is optional, no one see it.
Yeah, actually, whatever that thing is that everyone using for calendar clockwise, if it's optional, it can put on top of this meeting.
Mhm.
So I had to actually move some stuff because of that. Yeah.
Okay. Anyway, so I wanted to build order book DEX, and I did. If you saw Coinbase Pro.
Hey, Mike.
Hey, Mike. I might need to. You need to get access to Code Gem, not Code Gem, but the Whiteboard Gem. Okay, so I'm explaining that I wanted to build order book contract, and the idea is you have a bunch of orders here, and it's divided by some middle spread. So idea is you have orders where people want to sell. Let's say you have assets such as, for example, DAI near. I guess I can type instead. And people want to buy near and sell near. So let's say you want to sell at 1.6 DAI and you want to sell 200 near. And then you can sell at 1.7 and people want to sell 100 near and stuff like this. On the other side, you have a buy order, so people want to buy at 1.5 near. Gosh, how I select this? Anyway, and this is the order book on chain, which means on chain you have orders from different accounts, and they say, hey, I want to, let's say, sell at the given price, a given amount. Hey, Chad, I need you to give you a link in a chat. Now go back. So on chain, we need to be able to store orders. And then when a new order comes in, let's say I want to take order and I want to buy 100, or like I need 250. So this is my new order. I want to buy near at 100 or like 165 at 250 nears or something like this. And that will essentially match this order at 1.6 completely, and then that's it. So the next is there a way to select? No. So it's not good. So this part will be something like this. So it will transform. Hey, Peter.
Hello.
Nice haircut.
Can you share with Peter the link to the whiteboard?
Here it is in chat.
So after I submit my new order, which is this, well, I lost 1 second. I should need to remove this one. The order book will be transformed to this. So you have a new buy order of 165. The remaining limit is 50, and there's still a sell order at 170. This order will get matched. So you will have a new trade, which saying, I guess will be like sold at this price. The challenge here is how to actually maintain all of this on chain, because when you do something like this, the way to execute it, I will just start it through sell orders, and I went up and up and up until I have matches, and I just said all of them are matching. Now I put my order to the top of the buy list, and that's it. So this can be done in a linear time to the number of orders I need to match. And I always know from where to start. I always start from 1.6, which is the bottom of the list. But if I have a new order, let's say I want to now buy at 155, and I want to like say 300. So the challenge there is now I will need to move this order and stick my order inside. If this is pretty far from the top of the list, then I essentially will have to iterate through all previous orders to arrive at the given point. And it has its own challenges on the way you implement it. And let's say we're talking about thousands of orders on each side. If I want to stick my order somewhere in the middle, it will be problematic. Or if I want to remove my order, based on implementation of the lists, I need to again iterate through all orders until I find my order in order to remove. So we either have to like go in a linear time for putting new orders in, or we need to have some kind of way to skip a position.
Wonderful.
So, yeah.
Oh, go ahead.
So the way one plus these orders needs to be sorted. One of them is like reverse, and another one is like other side. So one of them is like decreasing, another one is increasing from the top. What did you want to say?
I haven't fully fleshed this out, but just the idea of like buckets, you know, I'm not sure how you'd have that be dynamic, but like this is a bucket that's like $1.35 up to $1.75.
Yeah, so this is called like a minimum or granularity on chains, that they limit the size first of all, and second the price step. And the size is limiting, so you don't have dust orders, which is like, let's say I want to only 0.001, and the price step is, let's say I only have 2 digits as well. So that both of them are limiting. Hey, Matt.
Mike, are you talking about each one of these being its own kind of bucket?
Yeah, I guess I'm trying to think in terms of like a smart computer science way to do this. Of like, so in the worst case that Eugene mentioned, where you have to stick it like to the second to last one, you have to iterate through. If this is a linked list, then you have to go through like from the beginning, like all the way down. And that's what we're trying to avoid here. Is that right? And also, are we even talking about linked lists right now?
But what if each one of these was like a queue that you just pulled orders out of, and it was like a queue for each bucket, like that? That's what I thought you were saying, Mike, because that's what I was thinking too. So like as you put an order in at the whatever the bucket you called it, $1 to $1.50 bucket, then you just get added into the queue, and like whatever the orders are that in the, like first in first out, whatever that they say about queues there, and then there's like if like whenever someone's ready to match that order, you just take from the front of the queue until you consumed it.
So orders, or like splitting into buckets, is somewhat similar to like skip lists. So skip list is the idea you have multiple layers of lists. They allow you to like go forward and steps. And Alex Kidanov pointed out that whatever skip list logic you would use, it's easy to get it in a bad shape. Like an attacker, which we dealing on like blockchain, so there's always an attacker. They will try to like break the assumption of logarithmic step forward in order to do this. The standard solution for this is something like a tree map or like a heap, where you have it already sorted, so lookups are linear, consumptions is usually also linear. Well, like not linear. A lookup a logarithmic, inserts a logarithmic, and consumption is like n log n, like logarithmic for one element.
What about a locking skip list?
Lock-in skip list. What is lock-in skip list?
Basically, if someone is, let me think.
Well, anyway, like this is the problem that I thought a lot, and the solution is it doesn't have to be done on chain, basically. So the way you do this is, let's say you have a front end that has track of entire list right now, and you know that you want to insert 156, let's say, or like 154. Now,
so wait, really
so
quickly,
you want to,
before you go too deep in this, what is the biggest problem with the skip list as in terms of like an adversarial attack?
it becomes unbalanced because you either rebalance the lock time and then you lose the advantage of having a skip list.
Right.
Like tree map is also linear, so either each iteration is actually becomes a log operation, which means a consumption from the skip list becomes a log operation because you need to rebalance the entire list. Like not rebalance, but like you need to update all layers after your consumption, like after you match in orders in the order book. So it becomes non-linear. So the simplest operation is you have a simple linked list, like one-way linked list. Actually, you don't need like two-way linked list. Starting from the top, that just points to the next element. And now the only problem is insertion and deletion. Insertion is a linear with just a sorted list, while consumption of the matching is also linear, but the constant for lookup. So the way you do, let's say you need this order. On a front end, you just say, well, where does it go? So you know it needs to go here. So you know the element after each you want to put it. So you can just give the element to the contract after which you need to insert it. So element will look it up in a constant time. Then it will just put this into this position and set the next element, like it point to the next element. It all works very well unless this element disappeared, so someone canceled this order. Now your transaction arrives, it's saying start from this position, it's not there, so you cannot really put this order in. So the way you do this is you can build this logarithmically or like some other way in the multiple hints that you want to start from. So let's say you want to start from this position, then you give another position, then you do another position like in 3, and then in 2 elements, then in 4 elements, and in 8 elements up to the top of the list. So your gas cost is kind of like worst case scenario, it will go to linear, but the good case scenario, it will start from there. So on average, if no one canceled your immediate order, you will be able to reach your position in a constant time, which gives us ability now to match each order in a constant time. So you can insert and delete orders also in a constant time using these hints. Like deletion is you just give your own order, and insertion, you need a bunch of hints from which you can start checking. Like if the hint is not available in the list anymore, then you go to this next hint, which is slightly farther.
I was thinking about a lot of stuff while you were saying that, so I might not have been paying as best attention as I could be, but like the hint itself that you're talking about, that's like, is that kind of equivalent to like where it needs to seek for the proper bytes? Like,
yeah,
is that what we're talking about here?
It's basically a seek position that you give. Then let's say this is my seek position. There was 5 orders after this. I'll just start iterating from them until I reach my location that I need.
That's like exactly what a skip list is, except now you're looking inside of each it's like just without indexing, right? Because you're basically saying you have A, and then 5 orders happen, and then maybe concurrently like something is going to drop at point D, or let's use numbers, 0.1 and 0.5, or 0.6. But then if 6 is like, okay, what if the same thing happens, right? And so then they're like trying to add an order at 0.7 that's conflicting with the original list that has now blown past 6 to 7. Does that make sense? Like you're like how do I know I'm at position 6 versus position 5 if I'm not the person who like is in the linked list that you're talking about up to position 5?
So you know your position, right? You know 2 elements between which you should put your order, because, well, once you arrive to this element, you know that you may be next. And once you see this element, that you know you are previous. So once you know a position in which you need to put, and yes, front end has entire list, and it can just use JavaScript to like linearly iterate to find all the hints and construct these seek positions that you would get from a skip list.
Am I wrong? Am I wrong in thinking that if you do it on the client, though, by the time the client's done, it's wrong, and that's like now you can use all.
Well, you don't pass the index, you pass the pointer essentially, like so you can jump for the pointer.
That's kind of cool. So like so wait, why don't we go back to the skip list idea, and then you have like a maximum number of levels in the skip list, and then you just send the levels to the client. So they know
you don't need to maintain the skip list at all. Basically, on a contract, it becomes even cheaper. So the way contract should optimize it is a minimum amount of read and writes, because dust is the biggest problem. And like, let's say you want to submit some large order. If there's a ton of dust, you'll just waste on it without ability to skip it.
Yeah.
So matching may fail, and like your entire order will just revert if you don't. So like people will pass 3,000 teragas or like 200 teragas maximum for this execution most of the time if their order is fairly large. To avoid like getting into state where they reveal their large order but not being able to pay for this.
Would it be shitty to force the client to basically make a bunch of find index requests in order to see if they're doing it right? So if you wanted to make an attack while there's a high volume of orders going through, you would have to pay a bunch in order to do it, just like figuring out if you're able to. Does that make sense? Like you basically have to check like what the last position is no matter what if you want to add to it.
Yeah. You always need to like the client or like the front end will track the order book precisely. Eventually it will be through indexer, so it doesn't need to requery it. So you just keep logs, like read logs from the contract, and you know that which orders were added, which orders were removed, so you don't need to like
going back
restore the entire.
Yeah, go ahead. Sorry.
This is super cool. This is super cool. Going back to like the hint, like so you're gonna be like if your front end is completely updated, then you can seek to around here, right? And then it goes to the linked list, and it kind of knows whether to go forward a certain amount. But I think it's true that like what Peter's saying is like a bunch of stuff could have happened, and in that case, the hint is still useful. But wouldn't we want it to be like backwards and forwards linked lists? So you still have the hint, but you're like, oh, actually some stuff has changed. Go back.
Well, so if you think about the reasons, then your hint will always be in the previous position of the list. So like both deletion and insertion requires you to deletion, you just point to your own, so it's constant always. But you need to know the previous one before you to delete the element, which may require you to pass the hint in front of you.
So by the time the transaction gets there, you can't be sure that you're only going to go forward, isn't that? I guess that's what I'm saying, and maybe I'm wrong here.
Yeah. So for deletion, no. So you always only go forward, because once you get a hint, right? Let's say your position is 154. You want to delete it. You need to know the previous position so you can update the list. So if you had a linked list, double linked list, then yeah, you just look back and update it. But that's an extra read or extra write every time you need to like stick something. Maybe we can keep it, but it's like it also increases memory of every order. Now, insertion doesn't save you from this. So like you know this position, it's straight in front of your next position, right? So you're saying something might change. So what exactly can change is there can be more position added after this, but it can never be became there, right? You never need to go back. Does it make sense? So like if you insert 54, it will never go in front of 55 because the position is always like sorted. So you know it always.
Okay, I must be missing something. I guess I was just presuming that like some people in the meantime may have fulfilled their orders and they're now removed, and so the hint is useful generally. But I guess I still don't see it, but I trust that you do.
So basically, what may happen is this order might be deleted by the owner without destroying the entire book and moving you to the top. In this case, what will happen is, well, this hint doesn't work anymore. No matter whether you go back or in front because this is not maintained anymore in the list. So you look it up, it's not there. It's already matched, so it's already deleted. So you need to go to the previous hint, which is maybe this element. So I guess you just pass a bunch of stuff in front of you, not necessarily logarithmically stepping up. And then if all of them are deleted, then you screwed and you just start from the top of the list. You always have head in the contract, so you can just try to iterate from the head of the contract.
I've got a kind of different topic question about this. Should I wait or can I ask it now?
No, go ahead.
It seems like you're kind of making this sort of fundamental assumption that we're talking about one contract and the data structure that contract is managing. Have you considered like splitting these buckets across contracts? So like you've got buckets of, some, 5 cents or 10 cents managed by different contracts. Because when you place the order, if I order, 1,000 things, whatever it is, if I want to sell 1,000 things at 150, I'm going to consume the 50, the 300, the 500, and the 1,000 in doing that.
Mm-hmm.
So you can process all that stuff in parallel. You don't need to do that linearly, right?
It's somewhat interesting. I haven't thought about this.
And
I guess what you can have is
the more general question, Eugene, is just like how do you think about like where do you put the lines in your design? It's as opposed to like one contract. Maybe where do you put the contract boundaries? Where do you put the method boundaries? That's the larger question. That was an example. So however.
So when I think about sharding, and in this case, I usually think about if it's a one pair and we need to maintain the pricing of this pair, then it has to be in one contract. It cannot go asynchronously because it will like deviate and it will be arbitraged and it will be unfortunate. At the same time, it should never be like multi-token contract because different players are completely independent from each other. They don't need to compete for resources in one contract. But splitting into buckets into multiple contracts doesn't really address a gas problem of a total limit. What you can do is you can say, hey, this is like high stakes pair. The minimum volume per order is blah. So like minimum granularity is 100. So like all your orders have to be at least 100. This way you can prevent dust and like price difference should be at least 1 cent between each other.
Did you say this way you can prevent dust?
Yeah, dust. Let me reiterate on a dust problem. Dust problem is when I put an order, which is, let's say it's a 154.9999, and I want to sell only 0001 near. So like front running this, here's my beautiful order, but you have to spend gas on like matching my order. You don't really gain anything from doing it. It will be in this stupid order book. So you cannot skip it. You're still going to spend gas on this, so why not match it?
It's an attack.
It's kind of like how exchanges like previously like front running some stuff for like figuring out if the order is coming in or some other stuff, but it's useless. So you would need to, for every pair, either define limits ahead of time, saying like, okay, you cannot create this order. The only order you can create is either like 54 or 55, and the minimum volume is like, let's say 10 near. So for example, Binance defines this granularity ahead of time for every pair, and it's usually based on the price. So like if your price is way lower, then maybe like this number has go up. So like they target some number per trade. So this way you fight dust, but there are still going to be like million of such orders, right? Of minimum volume of the same price. So like people can just keep sending this. And then if you want to like trade a large volume, then you will be limited by the dust there. So front end will help you fight it by saying, well, you don't need to send such a large volume because it will not be able to match it. You should only send like that volume, which is, or it can split it into multiple transactions from you. So it's like it can split it into multiple 200 teragas transaction that will match it, like this price, and then again this price, and like third time slightly higher price, and so on. So you will get multiple orders sent. Make sense?
And then when it comes to the front end, getting a bunch of these orders, I guess we would have to have a limit on that, right? Because it could be thousands that would run out of gas.
Right. Yeah. The front end should like try to like see how many orders you will match right now, and then send an appropriate amount, or like warn you if this happens. Because of like 1 second block times, if front end is smart enough, it will. So one ability is, so you can see there is no market orders in this model. Market order is easily front runnable because I can see, let's say you send a market order, you want to buy 5 near, I can just buy it all, put my order in front, and you will match my order, and then I'll just put it back on. So I just made money on your order if I spotted it ahead of time, like front run you in a position. So, but people want to be able to just like say, I want to buy without thinking about limits. In this case, what they do, they send an order that has execution algorithm, like not algorithm, but expiration. So order immediately expires after it matched a bunch of orders. So let's say I want to buy up to 154, but I don't want to keep my order in the order book. So I can send the limit order at selling in 154 at 850 total, and I say my order should expire after it matched, so like immediately expires. So what happens is it goes to chain. Let's say this order was matched by someone else. It started to match. It matched 800 total volume at this pricing, and then it's supposed to put my order in the top of the willing to sell. But instead, it will not do this, and it will just say, I only matched 800, it's okay. So it's kind of like a market order with slippage. You say, I want to buy at the board that I see, but nothing else. Like your front end essentially saying at the maximum slippage that you will get, and it may fail to fill the complete volume, but it will not stay or exceed the pricing. So that's how it works. And for implementation, it seems like I'll need to implement a new collection, something like a linked list that has indices and hints. And then there are a lot of stuff challenging with the front end. Later, how you actually update it without indexer, I have no idea. The only way is like either maintain some kind of rolling buffer of recent orders that were posted before you have indexer, because I need a constant time on this and like constant space to avoid storage explosion. Same for executed orders. Eventually, it will be indexer that can read events and get this information. But for now, it can also be a rolling buffer of matched orders. So let's say this order is matched, it will just move there. And this, like, maybe once it's out of space, it will just disappear or overwritten. So eventually, there may need to be a factory that creates it for any fungible token. So before you can trade, you probably need to register an account on this exchange, on this contract for this pair. That will allow you to start executing orders, and then you can send an order that will go in and try to swap one for another. If you send a market-like order that expires immediately, then you don't need an account because there's no balance for you. But if you send a limit order, then you first of all you pay storage for your limit order straight from your balance. So you need to know how many orders, active orders you have in the order book. And the second, you need to once it's executed, you need to put your balance back into your local account potentially. And that brings the pattern of like account registration per storage that is similar to fungible token standard. Okay, I'm done with my contract. We still have 15 minutes, so we can spend on what you want to build today if you want to hack.
So what are we doing with the time? Otherwise, can I just jump on the whiteboard and like throw out an idea of something and ask for feedback? Is that the point, or what?
Yeah.
Because like it's not nearly as mature as what you just presented. It seems like you've been thinking about this for weeks or months. So I don't have that much thought behind anything I would have to show. But I'd love some feedback.
Yeah, go ahead.
Cool.
Yeah.
So I think. Maybe I could just make a new sheet here or something like that. Okay, so I just made a new frame, okay. And I need to share my screen here.
Or I can share the screen if it's easier. Okay, it works.
Yeah, am I sharing it now?
Yes.
And then, yeah, so I'm here, I think. You can see me. I can't see the, yeah. So I was playing with this idea of an Oracle contract. Just to, it's going to be maybe a little bit simplistic for some of the folks on the call, but so there's some contract, and it has some methods on it, whatever those methods are. Wow, that's huge. So whatever these methods are, what I was thinking of is something like being able to say, request, some data, right? And we would pass in the thing that we're asking for. It could be like a stock symbol. I've seen examples like that, or it could be like a some SQL string. It doesn't matter what the request is, some arbitrary request. and then with this request, I would get something internally that would be like a kind of being added to a queue of requests, right? That would sort of fill like a stack or whatever. And so this would be like a list of requests that the Oracle is holding. This is maybe some Oracle contract, and if what I'm saying is nonsensical, just stop me. But this is how I'm thinking about it. So there's some contract. You can call it with whatever the request is that you want to be processed by the system that this is interacting with in the real world, and maybe we can do this as like a boundary between on chain and off chain. So this is off chain world here, and this is on chain world here. And so maybe we have some kind of some requests like this that I register. It gets added to some queue, and then maybe from off chain, I might have something that asks, is anything waiting, whatever, and so that's a call that then delivers the some item from the list, whatever the item is, to be processed, and then it goes through some process, and now it's it's ready, to go back, and so whenever this thing is ready, I guess we would need some other way to signal that. So maybe waiting's up here. We get, oh geez, I can't do that. And so this is, something's ready, and we would pass in like whatever the data is, the payload. And then and so we would ask, request would be number one here, and then there would be some queue, and then we would ask for waiting. What's waiting? We'd pluck something off the queue, process it, and then pass it back in, to the ready here whenever it's ready to be put back on chain, and then that gets added. This item gets checked off, and then maybe there's some this is the question of whether or not this makes sense. Maybe as part of this request, I sort of attach an account as a listener to this item whenever it's ready, and so this would fire off. I was thinking about this in the context of the cross contract calls. So this would be fired off here as soon as this item is ready. It would fire off and actually call back the other contract to let it know that the data is ready. Whoever the requester was that originally made the request. And then anybody else that makes a request that's similar to this could just be added as another listener, maybe in a different color or something like that, to a pending request, and so that that would go off to them as well, like wherever they are. So let me stop there. Does that make any sense? Having some setup like this where any contract can sort of request of this Oracle something, register as a listener for whenever the item is satisfied, and there will be some external interface that processes it, marks it ready internally, that state gets tracked, and then just notifies all observers.
Yeah, I mean, probably you don't need all observers. and you need some kind of payment to attach to each request.
Yeah,
so you
the
cover,
request,
first of all, temporary storage to keep the request.
Yeah,
if it's needed, if it's even needed, because we can use logs to pass the request. But
there's two fees right now. There's an Oracle fee and a cross contract call gas fee.
Yeah,
that you have to attach to the request. And
Yeah.
the Oracle fee is like 1 near or whatever for the request, and the gas fee is whatever 3 teragas or whatever the typical thing is. So you have to attach these when you're making the request, and it's validated inside the Oracle.
Yeah, so once Oracle actually replies, it can take the fee and fire event that goes to the requesting contract. What you also need is expiration that should be enforced by this Oracle contract. So let's say a request has to be executed within 5 seconds. Otherwise, let's say it's not valid anymore, and funds should be refunded back to the
and then probably
owner.
have the client be able to cancel their request if it hasn't been fulfilled within a given time. So this is
or like maybe not necessarily client, but anyone should be able to cancel the request after expiration, and like Oracle is covering certain guarantee fee. So like, let's say Oracle is still required to reply even for invalid request. It will just say invalid request instead of ignoring it. So maybe there's some standard SLA that the contract guarantees, such as like if the request became invalid, then someone can call it, collect the SLA fee, refund the request.
So this is like really similar to the Chainlink situation. Have you seen that, Sharif?
No.
Yeah,
I know that you and Josh did quite a bit of work on that, and the intention was there to look at it, but I haven't seen it. I've heard you talk about it, so maybe some of this is inspired from that.
Yeah, no, you're totally on the right track. This is like almost exactly how that works. The only difference I think is that you have the idea of listeners, or like someone else can kind of piggyback on. Like,
yeah,
hey,
if you
I want to know that too.
Request and it's in the queue and it's been processed, and if there's a response to it, there's also a timestamp on the response down here. I don't know how to signal this for you guys, but down here there's a timestamp on this. So this request was last processed, whatever, 24 hours ago or 3 minutes ago or something. So that way, if you need fresh data or whatever, you can force a refresh in the request, stuff like that.
What kind of data that would be useful to use this Oracle for? What kind of data?
I wasn't thinking about that. I was just trying to find an excuse to work with cross contract calls. So I didn't actually think beyond how to get something like this working in a way that was sort of like to motivate this part of it is all I was thinking of.
Yeah, to simplify, just remove multiple. Like you cannot attach more than one listener. That way, you always have the fee covered. Expiration, don't need to like penalize the expiration, just make it not it will not pay the Oracle fee if the expiration.
So right now the fee is discounted if you're asking for something that's already been processed, and it's shared if you're listening with someone else. So it's like a reverse auction kind of thing. So if four people are asking for the same piece of data, then you only pay for 25 cents of near to get that data.
Like,
popular data is cheap.
Immediately fulfilled. So unless you want to deal with like stale data, which you may do, but I'm not sure, like then it always like makes sense to always get a fresh request. And I assume what we also can do is some kind of like Oracle fee goes down exponentially with the delay. So Oracle is incentivized to immediately reply to your data instead of waiting for the closer to expiration to reply.
Oh, I
Maybe
see.
something
Yeah,
like
that makes sense. Mm-hmm.
I like this token economics. I just got this book actually yesterday. And so like applying some sort of like curves and whatnot.
What's the book, Mike? I missed it.
Whoops. Economics and
nice.
Math of Token Engineering and DeFi.
Oh, sweet, dude. It looks thick.
Yeah, it's like this. I thought it was gonna be bigger. It's like this big.
Yeah, nice.
That sounds awesome.
Yeah.
Did you start it?
I gotta run to I haven't started it yet. I gotta run to a grants meeting. Good stuff, y'all.
Yeah, I think we're done.
Eugene, question for you.
Yeah.
Gotta go, guys.
See ya.
Okay.
See you.
Bye.
I understand that.